Hello, students. It's Mr. Win here. Thank you for joining me. Today, we're going to be working on actually writing linear inequalities from word problems and solving them. Okay, so let's start with this first example here using IXL Practice. We have a problem that says a rock band has made a souvenir t-shirts to sell at their concert and hopes to bring in at least. So we see some keywords here, at least. I'm going to underline these keywords, okay? At least $100 from the sales of the shirts. Okay, they make 400. They make $4 for each adult T-shirt. So we have one variable here, which is adult T-shirts, and $2 for child T-shirts, right? So we have two variable here. Let's call this the X variable, which is down here. That information it's telling us down here, and then the Y variable would be the child T-shirt, right? Which is also done here for you. A lot of word problems will not give you this information. Okay, IXL is just being nice. So let's put all of this into a mathematical context. So what does at least mean? At least means you can have um, more. Let's say if your mom gives you at least $5, that means she can give you $5 or more than that, right? But she cannot give you less than that. So at least means cannot be less than. So at least mean cannot be less than. So let me type that out so you can see it. At least means it means cannot be less than. Well, if you cannot be less than, that means you must be greater than or equal to. And this is actually the algebra context that we need, right? So greater than or equal to would have that symbol. So right off the bat, we have to know that we are going to make more than $100, or $100 is fine. Okay, so at least means greater than or equal to. So in this case, it's going to be greater than or equal to $100. So right off here, we know that this answer will not work. This answer will not work because I have to have an equal sign um, in my inequalities, right? So now we are choosing between these two, but which one is going to make more sense? This one says whatever the number of shirts you sell, you're going to add 4 to it. Well, if I sell 5 shirts, I add $4 to that. That means I only make $9. Is that correct? If each adult shirt, it's $4, then if I sell 5 of them, I should be making $20 because it's 4 times that, right? So always take this number and actually multiply it with the variable to get the amount, right? So this answer makes a lot more sense, okay? So we're going to pick that answer choice. Let me go back to my thingy here and select that. Submit. Submit. Oh, my computer's a little slow. All right, come on. There you go. Good work. Okay, let's try the next one here. Jennifer's purchasing chocolate truffles. I cannot speak. To use as party favors. So, blah blah blah. All of those are minor detail. To ensure that they have enough for everyone, she needs to purchase at least. Here we go. As we see the word at least 58 pieces. Okay, so at least again, we know that that's going to be this simple, right? If you are taking note, you should be writing this down. This inequality symbol that I'm using here is for at least, okay? Dark chocolate, again, dark chocolate truffle is going to be our first variable right here, which is the X variable, number of dark chocolate truffle boxes. And then, comes in 15 pieces. So you remember we take the number and we multiply by the variable. So right off here, we know that this is going to be 15X, okay? And then for number of milk chocolate is going to be our Y variable, right? And it comes in boxes of 29 pieces. So right off the bat, we know that this variable goes with the number 29. and together they make the whole entire purchase, right? So together they make the entire purchase. So let's see. This one will not be the answer choice because it's that's not at least, right? So all of these are good, but which one will say 15x plus 29y? Okay, this one is not good because the symbol is wrong, right? That one's says less than. So we should go with this answer choice right here. This plus that is greater than or equal to 58 right there. At least. This means at least, right? Okay. So this symbol right here means at least. So make sure you write that down somewhere on your notepad or in your notes, okay? And we're not looking to multiply the amount. We're looking to add the amount together because the purchase including this and this, right? The word and means adding, okay? So here's the word and. It means plus, okay? Not multiply. So I'm going to go with that answer choice and let's see. Yeah, okay. I knew it. Um, I guess we can do one more and then we can maybe skip around and see what kind of problems we run into next. I want you guys to be able to see some challenging problems as well. So, all right, we're printing something here. So it's printing copies for a presentation. It says take 3 minutes to print color copy. So right off the bat, you know that this 3 is going to go with this variable for color copy, which is generally X. You can call it C if you want. All right. And then 2 minutes to go to make black and white copy. Okay. So the non-color is going to take 2 minutes. So that's going to be your Y variable. So right off the bat, you know the 3 is going to go with this variable. So it's going to be 3x. The 2 is going to go with this variable, so it's going to be 2y. All right, and together, right, together, because it says and means I'm adding, right? And means I'm adding. So together, this plus this, what is this? Has to be under. Here's the keyword for our inequality. Under means under. Let me type that out so you see. Under means less than, okay? Not equal to, that's less than because I have to be under that, right? If I'm gonna go and spend under $5, then it has to be like $4.99. It can't even be $5, right? Under $5, that's what under means, okay? So my symbol for inequality is gonna be this right here, less than, right? And then 56 minutes. And so we're looking for an inequality that says this. All right, so which one is that? That looks correct. Oh, this is actually not correct. It looks like it's correct, but the numbers are wrong. You see that? The 2 doesn't go with the x. The 3 is supposed to go with the x. So this is the correct answer. Now this one should be eliminated because it's minus. This one should be eliminated because it's multiply, right? So the one mistake that students could potentially make would be picking this one, which is wrong because the variables and the coefficients don't match, okay? So don't pick that one. We're gonna pick the last answer choice here. Submit. Fantastic. Okay, next one. I actually we're gonna skip. All right, we're in the I guess intermediate one. So this one we're actually gonna have to start from scratch, and we're actually gonna have to write them ourselves. We don't have multiple choices anymore. So let's go over the same process again, right? Underlining keywords and numbers, and identify our keyword for inequality. So we have we're doing something. We're making treats, right? For a party. So we have to use 15 eggs. We have to use up to, up to. So this is our keyword for inequality. So up to, what does up to mean? Up to means I can spend less than or equal to that amount. That's what up to mean. It says if you can eat up to 2 cookies, that means you can eat 1 cookie or 2 cookies. You cannot eat 3 cookies. So also means not greater than. So if I'm not greater than anything, that means I could be less than or equal to it, right? So the word the phrase up to means less than or equal to. And then I know the 15 is going to go right after that, right? So that's these are known as keywords for inequalities. Okay, now let's look at our variables. We have cones. No, not cones, scones. Scones is going to be 1x. So this 1 is going to go with this variable. So it's 1x, right? And typically in algebra, we don't, if a coefficient is a 1, we don't even have to write it. So we can just write x. It's understood that it's just one of them, right? And then tarts would be the y variable right here. Tarts would be the y variable, and it requires 4x. So that number 4 is going to go with the y, all right? And I'm going to be adding them because of the word and this, right? So I'm going to be writing 1x. And again, you don't have to write the 1. You can just write the x, right? Plus 4y. Oops, I forgot to put the 4 there. 4y is less than or equal to, using this symbol right here for up to, and then 15, okay? So I'm just sort of putting the pieces together to get my whole inequality. So let's type this in. We have x, and then we have an operator, which is plus, and then we have 4y, and now I'm going to use one of these symbols. It's going to be less than or equal to, so I'm going to be using this one, and then it's going to be 15, okay? So that's our inequality. Submit. Awesome. Okay. Let's try this again using the same strategies, guys. Same strategies. Okay. We have regular sized box. So I know this is going to be one of my variable. Okay. Forks. It has enough for 24 guests. So we have enough forks for 24 guests. So the number 24 is going to go with the forks. So the forks is the x variable. So I would call it regular forks, and we have value packs forks. So expensive, cheap, expensive, cheap. That's the way I look at it, right? Just to make things easy to understand. So the expensive forks are going to be the x variable, and it's going to be 24 important guests, I guess. Why would some guests get the regular forks and some guests get the value packed? I don't know. So anyway, we're gonna go. The 24 is gonna go with the X, and then the value packs. We have enough for 32 of them. So oh, actually, this is just to decide which is the better purchase, actually. So 32 is not about the guess. It's about what kind of purchase can you make that is good for the money, right? 32y. Okay. So there you go. So the numbers go with the variable, okay, and it's multiplication. And then we have to have at least for 76 guests. So at least means, again, we learned the word at least a few problems back. At least means I can be more than that, right? I can also equal to that, right? So at least just mean not less than. Not less than mean greater than or equal to, okay? And then the 76 will go with that. And then these two will be adding together because we have these guests and these guests, right? So we put 24x plus that 32y greater than or equal to 76. So that's what we're going to be typing in. I'm not going to write it again just to save time. 24x plus 32y, and we're going to use the symbol greater than or equal to 76. Okay, submit. Ta-da, brilliant. Okay. Let's jump level. I like to do a couple more problems, but I want to do some more challenging problems. So we're in the challenge zone right now. So let's see. I don't think it's any different, really. We're just writing these, right? We're not even solving them, are we? No, we're not even solving them. We're just writing them. So, okay. Let's look for some keywords here. We have an 8-inch cake. 8-inch cake, that sounds like a variable. Yep, it is right here. It's x, right? And then of course the number 22 will go with that, right? So here I have 22x, right? 22x so far. And then of course I have a 12-inch tier cake, and the number 34 will go with that. So a 12-inch tier will feed 34 guests. So that's going to be my y variable. And sorry, I'm at school, so Maybe I'll pause this. All right, I'm back. I apologize for that. I'm at school, so we are constantly interrupted by these. And there's my alarm. We're constantly being interrupted by these. There's the bell. Sorry about that. Back to the problem. 34 goes with the y variable. So, and then of course we're going to be adding them together, right? Because we have all of these guests together. And it says again, at least 177. So again, at least it's greater than or equal to 177. So now we know what to type in, right? We're going to type in exactly what I just wrote there. 22x plus 34y, and we're going to use the symbol greater than or equal to because it means at least, right? And then we're going to submit. Ta-da. Yeah, super. Okay, we're at 91. Maybe I'll do a couple more. Okay, just a few more, like maybe one or two. All right, this one, because the concept is actually pretty much the same. The number goes with the variable, the number goes with the variable, and then look at the keyword for the inequalities, right? Keyword for inequalities. We have roses and carnations. These are the two different flowers that we're going to be using to arrange for flower arrangement. And here they are. Okay, I would have column R and C, but X and Y are a lot easier to refer to, as long as you tell your reader what X stands for and what Y stands for. Okay, and then we don't want to spend more than that. So not spending more than 35. That means you can spend exactly $35. That means we do have an equal sign. Okay. So no more than, let me type that down. No more than means you can spend equal or greater or less than. I'm sorry, less than. No more means less than. Okay. That amount. Okay. So, oops, can't type. Okay, so, oops, I can't spell either. No more than means you can spend equal to or less than that amount. So, no more than equal to or less than that amount. So, less than or equal to. So, no more than sometime is known at most. At most. That's what it means, okay? No more than means at most. So sometimes you will see this the phrase at most in your problem. So it means the exact same thing. So at least is the other way, and at most, of course, is less than or equal to. Okay, so anyway, where am I? No more than how much? $35. Okay, and so here we have $5.03 that goes with the roses. So the rose is the x value. So we know that that number 5.03 is going to go with the x variable. So that's what I'm going to do. I'm going to take the amount that it cost and multiply by each rows. Okay. And then, of course, the $2.04 will go with the y variable. And you actually have to type it in exactly as um, the number says. And of course, we add them together to bring us to the entire budget of $35. Okay, so let's type this in using that. So I'm going to do 5.03x plus 2.04y, and it's going to be less than $35. Okay, and that is my equation, or actually rather inequality that represent this situation. So submit. Awesome. All right, one last problems. Okay, I spent too much time on that interruption. Janet is building shelving units to hold all of her shoes. Well, Janet has a lot of shoes. She has work shoes. Okay. Well, Janet only has two types of shoes. She has work shoes and she has boots. All right. So we have two variable here, work shoes and boots. Okay. So work shoes take up this much space, 1.4 square feet. And then boots take up this much space. Okay. So they're much bigger. They're a lot bigger. The total amount of shelving, again, I'm looking for numbers and variable so that I can put them together. So 1.4 will go with the x variable, because those are just normal shoes. And then 3, we'll go with the y variable because these are boots, okay? So, and then of course we're going to add them together to get the total amount of space, right? Okay? So what we're trying to find is, if we were to solve this, is how many shoes and how many boots you can fit in its little space, okay? At most, here's the word at most that I was talking about earlier. At most means the same thing. You can be less than or equal to, okay? If your mom said you can spend at most $40, then you can spend exactly $40 or less than that, right? So less than or equal to $40. And there goes another interruption. There you go. This is what you get when you're at school and making videos. So let's type this in so that we can be done with it and not get interrupted again. So plus 3y, you don't have to put spaces in here when you're typing these. So but I think it will still count it right, even if you did put spaces in there, right? So there is our inequality. Yes. Okay. And so, guys, I hope you guys that was helpful. So try it yourself, and see how you do. And let me know if you have any questions. Thank you so much for watching. I will see you in the next video. Bye bye.